Time. It's the most familiar of concepts, something we all think we understand, yet also the most baffling. It's a concept that has intrigued and perplexed humanity for millennia. We experience it every day, every second. It marches forward, relentlessly, never pausing, never stopping. But what exactly is time? Is it a tangible entity or just an illusion? Where does it come from? Did it begin with the birth of the universe, or has it always existed? And where is it taking us? Is there an end to time, or does it stretch infinitely into the future? These questions have puzzled philosophers and scientists for centuries, from the ancient Greeks to modern-day physicists, and the answers remain elusive. Despite our advances in science and technology, time remains one of the greatest mysteries. We can measure time with incredible precision, down to the tiniest fractions of a second. From the ticking of an atomic clock, which is accurate to within billionths of a second, to the cycles of distant stars which have been used to track time for millennia. But these measurements only tell us how time behaves, not what it truly is. They give us a way to quantify time, but not to understand its essence. Is it a fundamental property of the universe like space or matter? Or is it something more abstract, a concept created by our minds to make sense of the world? Some theories suggest that time is woven into the very fabric of the universe, inseparable from space itself. This idea, known as spacetime, is a cornerstone of modern physics. Or is it merely a construct of our minds, a way for us to make sense of the ever-changing world around us? Our perception of time can be influenced by many factors, from our emotions to our environment. We see time in the changing seasons, in the growth of a child, in the aging of our own bodies. It's a constant reminder of the passage of life. The study of time takes us on a journey to the very edge of human understanding. It challenges our perceptions and forces us to think in new and profound ways. It forces us to confront the limits of our perception, to question what we know and to explore the unknown, and to question the nature of reality itself. Is time a fundamental part of the universe, or is it something we have created to make sense of our experiences? It's a journey full of wonder, mystery, and profound implications. The more we learn about time, the more we realize how little we truly understand. So buckle up and prepare to explore the universe's greatest mystery, time. It's a journey that promises to be as endless and fascinating as time itself. For centuries, the prevailing view of time was shaped by the work of Isaac Newton. His contributions to science and mathematics were monumental, and his theories laid the groundwork for our understanding of the physical world. In his monumental work, Principia Mathematica, Newton described a universe governed by absolute, unchanging laws. These laws were seen as the ultimate truths, providing a framework within which all physical phenomena could be understood. Time, in this Newtonian universe, was a constant, flowing at the same rate for everyone, everywhere. It was like a river, moving steadily forward, unaffected by the events happening within it. Imagine a cosmic clock, ticking away with perfect regularity, marking the passage of time for the entire universe. This clock was the ultimate timekeeper, ensuring that every moment was measured with precision. This view of time, often referred to as Newtonian time, provided a comforting sense of order and predictability. It suggested that the universe was a well-oiled machine, operating according to fixed rules that could be understood and predicted. It allowed scientists to make precise calculations and predictions about the movements of planets and stars. With Newtonian time, astronomers could chart the heavens with remarkable accuracy, predicting celestial events years in advance. The universe, in this model, was like a giant clockwork mechanism, with every gear and spring moving in perfect harmony. Each component played its part in the grand design, contributing to the overall order and stability of the cosmos. However, as our understanding of the universe deepened, cracks began to appear in this neat and tidy picture. New discoveries and observations started to challenge the idea of a perfectly ordered, clockwork universe. Scientists discovered phenomena that couldn't be explained by Newton's laws alone. These anomalies hinted at a more complex and dynamic reality, one that required a new framework to be fully understood. The speed of light, for example, seemed to be constant, regardless of the motion of the observer. This was a puzzling observation, as it contradicted the Newtonian idea that time and space were absolute and unchanging. This observation challenged the very foundations of Newtonian physics and paved the way for a revolution in our understanding of time. Enter Albert Einstein, whose theory of relativity would forever change the way we perceive the universe. A new vision of the cosmos was emerging, one where time was not absolute, but relative, fluid, and deeply intertwined with the fabric of space itself. Einstein's theories revealed that time could stretch and contract, depending on the speed and gravity of the observer, leading to a more intricate and fascinating picture of the universe. This new understanding of time opened up a world of possibilities, from the warping of space-time around massive objects like black holes to the concept of time travel. It showed that the universe was far more mysterious and wondrous than we had ever imagined. As we continue to explore the cosmos, our understanding of time will undoubtedly evolve. Each new discovery brings us closer to unraveling the mysteries of the universe, and with it, a deeper appreciation for the intricate dance of time and space. Time, once thought to be a simple, unchanging arrow, is now seen as a complex and dynamic force, shaping and being shaped by the very fabric of the cosmos. It is a reminder that our journey of discovery is far from over, and that the universe still holds many secrets waiting to be uncovered. As we look to the stars, we are reminded of the profound and ever-changing nature of time and the endless possibilities that lie ahead in our quest to understand the universe. In the early 20th century, Albert Einstein shattered the Newtonian view of time with his groundbreaking theories of special and general relativity. Before Einstein, time was considered a constant, an unchanging river flowing uniformly for everyone, everywhere. Newton's laws had painted a picture of a clockwork universe where time ticked away at the same rate, regardless of the observer's position or motion. Einstein proposed that time is not absolute, but rather relative, meaning that it can flow at different rates for observers who are moving relative to each other or experiencing different gravitational fields. This was a radical departure from the Newtonian concept and required a complete rethinking of how we perceive time and space. Imagine two identical clocks, one on Earth and the other on a spaceship traveling at a significant fraction of the speed of light. The clock on the spaceship would tick more slowly compared to the one on Earth. This isn't just a theoretical idea. It's been confirmed by experiments involving high-speed particles and precise atomic clocks. According to Einstein, time would actually slow down for the clock on the spaceship relative to the clock on Earth. This effect becomes more pronounced as the speed of the spaceship approaches the speed of light. The faster you move, the slower time passes for you, relative to someone who is stationary. This phenomenon, known as time dilation, is one of the most mind-bending consequences of relativity. Time dilation isn't just limited to high speeds, it also occurs in strong gravitational fields. For instance, time runs slower near a massive object like a black hole compared to a region of weaker gravity. Einstein's theories revolutionized our understanding of time, showing that it's not a rigid, unchanging backdrop to the universe, but rather a dynamic and flexible entity that's intimately connected to space. His equations demonstrated that mass and energy can warp the fabric of spacetime, bending it and stretching it in ways that were previously unimaginable. His work revealed that time and space are not separate entities, but rather two sides of the same coin, forming a unified fabric known as spacetime. This concept of spacetime is fundamental to modern physics, and has led to numerous discoveries and technological advancements. This revolutionary concept of spacetime has had a profound impact on our understanding of the cosmos, from the behavior of black holes to the expansion of the universe itself. It has opened up new avenues of research and has deepened our appreciation of the intricate and interconnected nature of the universe. Einstein's insights continue to inspire scientists and thinkers, pushing the boundaries of what we know and challenging us to explore the unknown. Today, the legacy of Einstein's theories lives on in the work of modern physicists who are exploring the frontiers of space and time. From the search for gravitational waves to the study of quantum mechanics, the principles of relativity remain a cornerstone of our quest to understand the universe. As we continue to probe the mysteries of space-time, we are reminded of the profound truth that time is indeed relative, and our journey through it is shaped by the very fabric of the cosmos. One of the most intriguing illustrations of time relativity is the famous twin paradox. Imagine identical twins, let's call them Alice and Bob. Alice stays on Earth, while Bob embarks on a high-speed journey into space aboard a rocket that travels at a significant fraction of the speed of light. According to Einstein's theory of relativity, time will pass more slowly for Bob than for Alice. So, when Bob returns to Earth after his journey, he will find that Alice has aged more than him. This difference in aging is not just an illusion, it's a real consequence of the different paths they've taken through space-time. The twin paradox highlights the bizarre and counterintuitive nature of time dilation. It demonstrates that time is not a universal constant, but rather a relative quantity that depends on an observer's motion. The paradox also raises profound questions about the nature of time travel, suggesting that it might be possible, at least in principle, to journey into the future by traveling at incredibly high speeds.